So physical quantities could either be defined like anything that could be measured, as well as a quantity which has both magnitude and unit. For example, 9. Would you consider it a physical quantity?
Yes, sir.
Would you? I just told you that it is a quantity which has both magnitude and unit.
Oh, okay. So,
It would become a physical quantity if I write. Sorry, do you know? Do you have an idea about what force is? The unit of force?
yes, sir. It's measured in Newton.
Yes. So if I write it as 9 Newton, then it has both the magnitude and a unit. But before that, I only wrote 9. So it's only the magnitude, but not the unit. So I will not call it a physical quantity. So physical quantity could be understood in two ways. One is anything that could be measured, and the other way is if a quantity is written. Well, if you see something on written somewhere and you see a magnitude and a unit alongside with that would be known as a physical quantity. What is magnitude? Magnitude is basically the amount of that substance. In easy words.
Okay, sir.
For example, if I say 10 balls, so 10 is the magnitude. It tells us the amount of that substance. Okay, but I am not going to say it. Okay, let's leave that. The physical quantity is further divided into two parts. That is base quantity and derived quantity. Since you must have reached to this portion, can you tell me what is the difference between the two?
So, because quantities are those seven SI jewels which are uh, fundamentally in measuring we will drive quantities are those quantities where any combined base quantities to have uh,
Yeah, pretty much the same. Let me simplify it further. If I can measure a quantity directly, okay? If we can measure anything directly, that I do not have to depend on other quantities for its measurement. It's a base quantity. Okay? For example, in order to measure time, do I need anything else? I could just directly measure time with the help of watch. If I want to measure a mass, do I need to require anything else?
no sir.
But what if I want to measure force? What two things do I require? Do you know the formula for force?
Self force is equal to ma
Yeah.
mass
So
times x.
in order to calculate force, I require both mass and acceleration, which means force and mass. Which one is the base quantity out of force and mass?
Mass is base quantity, force is
Yes.
drive quantity.
And why is that? Because mass could be measured directly. That's why it's a base quantity. And for force, I need to measure mass and acceleration first to get to the force thing. So the difference between a base quantity and a drive quantity is that if we can measure anything directly, it's a base quantity. And if it depends on base quantities, depends on base quantity, it's the drive one. We have only 7 base quantities which we can measure directly, and that is, you named a few: mass, time, length, electric current, temperature. Anything that comes to your mind that you can measure directly, which is not mentioned up till here.
So amount of
Yeah,
substance,
amount of substance. And the last one is
light.
intensity of light. Since it's a base quantity, it also have units as well, and the unit of mass is kilograms. Base in terms of base units, we will always use kilograms. We know okay, we have other units of this as well, pounds, ounce, and so many other. But when it comes to base quantity, or the examiner asks us to write something in the base quantity, we're always going to use kilograms for mass. Then for time, we have seconds. For length, we have meter. For current, we have ammeter. The temperature, we have Kelvin. For amount of substance, we have mole. And for light, we have, what do you have for light? Candela. Okay?
Okay, sir.
अच्छा, प्लीज कंफर्म कोई आवाज. लेट्स से डेंसिटी की बात करते हैं. डेंसिटी किसकी इक्वल होती है? मास per unit volume. In order to calculate density, I need to calculate mass and volume first. If I discuss about velocity, we need distance, displacement, and time. We discussed force. We need mass and acceleration. ठीक है? So drive quantities and their respective units are the ones which depend on base quantities for the measurements. And base quantities are only seven in number, and the following are the ones. Then physical quantities ho gaya. Example of physics is based on physical quantities. Differentiate between physical and base quantities. Seven base units. Scientific notation. What prior knowledge do we have for scientific notation? Motion is basically divided into two parts. That's kinematics, or we can discuss motion in two ways. You can also say that. And dynamics. Kinematics is the one where discussion or mentioning of force is not important. Would not discuss the application of force in this type of motions. Okay?
Yes, sir.
Whereas when it comes to dynamics, it's mandatory to discuss about force. कि कितना force लगा, किस direction में लगा, what was the role of force into that. So the motion is divided into two sections, kinematics and dynamics. If we discuss motion without discussing force, or the discussion of force is not important or requires, that type of motion is known as kinematics. अब what is that kind of motion? आपने example उसकी पढ़ी हुई है. कौन कौन सी थी? Velocity था, acceleration था. तो ये जो वेलोसिटी एंड एक्सेलरेशन होता है, दिस इज इसके अंदर हम लोगों ने मोशन की एप्लीकेशन, मोशन तो था, बट वी डिड नॉट डिस्कस द एप्लीकेशन ऑफ फोर्स इनटू दैट. व्हेन इट कम्स टू डायनामिक्स, डायनामिक्स में हम लोग, डायनामिक्स में मोशन नहीं होता, बट एप्लीकेशन ऑफ फोर्स इज इंपॉर्टेंट. लेट्स से मोमेंटम, which is which we are going to discuss in this chapter. तो सबसे पहले उसने चैप्टर के अंदर क्या बोला हुआ है? Let's state that mass is a measure of quantity of matter in an object. We know that. And मास का यूनिट क्या होता है?
Sir, kg.
मास का यूनिट होता है kilograms, and it's a scalar quantity. And how do we define it? The amount of
Uh,
matter in a substance, or quantity of matter. Quantity of matter. जैसे बोला है कि explain the mass of an object. Do you have an do you have any idea what is meant by inertia?
yes, sir.
Okay, go.
So, inertia is it uh, uh, tendency of an object to remain in its current state.
Yes, a property of a body due to which it resists any change state of rest or uniform motion. So inertia depends on mass. The greater the mass, The more this property would exist. For example, if I have a football and a bowling ball coming towards me, which would be easier to stop?
So
A football,
football.
obviously. And the reason behind that is because it's lighter in mass. The greater the mass of an object, the difficult there would be to change its states, whether it's at rest or already moving. Similarly, if I have a toy car versus what is a real car, it would be much difficult to start or stop the car. Because the real one. And why is that? Because it is due to the inertia. It is due to the mass. So inertia depends on mass, and we're going to discuss another property which is going to be momentum. वो motion पे depend करता है हमारे पास. ठीक है? So inertia is something which we have defined already. Okay, it would resist any change in state of rest or uniform motion, and it depends on mass. The greater the mass, acha, it is also known as Newton's first law of motion. Law of inertia we get them. Law of inertia is also Newton's first law of motion. There are three laws of motion, out of which the first law is based on Newton's law of inertia. Newton's first law also states that an object would continue its state of rest or uniform motion unless an external force is applied on it. For example, if a book is sitting on a table, or if a car is standing, it would not start moving on its own until unless it is and some force is applied onto it. So Newton's first law states that an object will remain in its state until unless an external force is applied on it. Let's say if a car is moving, I want to stop it. What would I do?
I say press the brakes.
I will press the brake. Or there might be a question case, sir. Agar if I stop giving the speed as I just take off my foot off the escalator, नहीं escalator नहीं accelerator शायद होता है. तो उसमें क्या होगा? The car would eventually stop. But let's not forget the car is not stopping because we took off our foot off the accelerator. It's because of the friction between the road and the tire. So the external force is given by the friction between the road and the tire. So Newton's first law states that an object will continue its state of rest or uniform motion unless an external force applied on it. So does the law of inertia. Inertia भी हमें यही बताया था ना कि वो रेजिस्ट करता है अपनी चेंज के अंदर whenever it's going to be, और वो किस वे में होता है? फॉर एग्जांपल, if I am sitting in a car, suddenly brake apply होता है, what would happen to us?
So we would go
कहानी निकालना.
forward.
हम्म.
So our body will go forward.
Will be pushed forward. Similarly, if I'm sitting in a bus and the bus take a sharp turn, what would happen to us?
So we
Will be pushed inwards.
yes sir.
ठीक है? So why did this happen? This happens because of inertia. Because our body would try to stay in that particular state in which it was before that particular change. So हम हमारे जब हम sudden car brakes apply करते हैं, why is our body is pushed forward? Because our body was already going in the forward direction. When a sudden brake was applied, so it would resist. That's why we wear the belts. सीट बेल्ट हम इसलिए पहनते हैं. सो inertia को डिस्कस हम इसलिए करते हैं because it is the reason that justify that why there is a certain change in our position when a brake is applied or the car is changing turn or whatsoever is happening. If we bring it to a change, it would resist that change. Okay.
Okay sir.
Then the next thing is calculate and define weight. How do we define weight?
So when gravity is idea on the mass, the force that is applied on mass is called
Yeah.
as weight.
Yes. वेट को हम अगर हम अदर वर्ड्स में बोलें, द फोर्स विद व्हिच द अर्थ अट्रैक्ट्स द बॉडी टुवर्ड्स इट्स सेंटर इज नोन एज वेट. व्हाट हैपेंड? होल्ड ऑन. स्क्रीन ऑफ हो गया ना? So on contrary to mass, weight is mg and is measured in newtons and is a vector quantity. Acha, since we have skipped those two chapters, we do know that na physical quantity is further divided into two sections, vector and scalar quantity.
Yes, sir.
And we do know the difference between these two clearly, head to tail rule and
Yes, sir.
everything.
Yes, sir.
अच्छा जी, वेट को कैसे डिफाइन करते हैं? यू टोल्ड मी दैट. वैसे जनरली हम कहते हैं द फोर्स, वेट इज अ टाइप ऑफ फोर्स. ठीक है. सो फोर्स विद विच earth attracts the body towards center. तो वेट W से होता है, इट्स mass into gravity. G is also defined as gravitational acceleration. G is gravitational acceleration. Why do we call it an acceleration? Because it
Sir,
brings motion into object. I think so. The screen stopped sharing now. The mass and weight का major difference तो हम लोग already discuss कर चुके हैं. And what was that? उनकी definition तो हम लोगों ने discuss कर ली है. जो remaining कुछ points रहते हैं हम उनको discuss कर लेते हैं. And that is only in terms of mass is a scalar quantity. Mass is the amount of matter या quantity of matter. And उसके लिए measurement है. Mass को measure करने के लिए हम लोग physical balance use करते हैं. And weight के लिए हम लोग जो है न्यूटन मीटर भी यूज कर सकते हैं. वैसे न्यूटन मीटर फोर्स के लिए यूज होता है. वी कैन ऑल्सो यूज जो यहाँ पे ऐसा लिखा हुआ है ना, फोर्स मीटर इज ऑल्सो नोन एज न्यूटन मीटर.
okay, sir.
इट्स ऑल्सो नोन एज न्यूटन मीटर.
Yes, sir.
स्प्रिंग स्प्रिंग बैलेंस भी हम यूज कर सकते हैं. न्यूटन मीटर और फोर्स मीटर सेम सेम ही है. बस दिस इज द ओनली डिफरेंस. फर्दर ऑन हम बताते हैं. हाँ, एक और सॉरी एक मेजर डिफरेंस होता है. मास रिमेन्स सेम एवरीवेयर. इट रिमेन्स same everywhere. It's not going to change. Whereas weight depends on the value of G. If G is bigger, weight is going to be bigger. If G is smaller, weight is going to be smaller. Because we know the formula of weight is W is equals to mg. So if mass is going to remain constant, the only thing that is changing is the force of gravity. So if gravity is changing, so is the weight of the object. So on different planets, weight is going to remain constant and जो mass है वो change होगा accordingly. Okay?
Okay, sir.
एक और छोटा सा पॉइंट है, बस ये डिस्कस करें, then we'll move on to the our next subject, contact and non-contact forces. इनका बेसिक बस एक बेसिक कर लो कि if two forces मतलब the contact is important between the two objects to force that force to be applied. It's known as contact forces. और non-contact forces वो होती हैं जो कि without contact of the two bodies could act on them. For example, अगर हम लोग इलेक्ट्रिक फील्ड की बात करें, सॉरी इलेक्ट्रिक फील्ड की बात करें, ग्रेविटेशन फील्ड की बात करें, दैट इज गोइंग टू एक्ट ऑन इट नो मैटर व्हाट वी आर इन कांटेक्ट विद द सरफेस और नॉट। ठीक है। ऑन द कॉन्ट्रेरी, अगर हम लोग बात करें फ्रिक्शन की बात करें, फ्रिक्शन इज ओनली गोइंग टू एक्ट ऑन एन ऑब्जेक्ट इफ द टू बॉडीज आर इन कांटेक्ट विद ईच अदर। तो इफ टू बॉडीज, मैं टू फोर्सेस लिख दिया, फॉर फोर्सेस टू एक्ट, contact force, two objects must be in contact with each other. For example, फ्रिक्शन, एंड नॉन कांटेक्ट में हमारे पास कौन सा आ जाएगा? They act no matter if the two bodies are in contact. For example, gravity or gravitational force. Okay.
Okay, sir.